In this video, we're going to discuss what the average rate of change tells us about a specific function. And there's two important things to keep in mind when you try and do these interpretations. The first is that the average rate of change will tell us the change in our output that we expect when we increase the input by 1. The units of an average rate of change for a function will always be the output per input, or specifically per one input. So let's look at a basic example, and hopefully this will help us understand what the average rate of change is telling us. Let A of t be the value of an account in dollars t years after it was opened. Find the average rate of change from t equals 2 to t equals 4 if A of 2 equals 1200 and A of 4 equals 1600. Interpret the meaning. So let's think about what A of 2 equals 1200 is telling us. A of 2 equals 1200 means the value is $1,200 after 2 years. And A of 4 equals 1600 means the value is $1,600 after 4 years. The average rate of change is the change in outputs over change in inputs. The change in outputs would be 1,600 minus 1,200 over 4 minus 2. What this is showing is a $400 increase in 2 years' time. So the account went up $400 in 2 years, or in other words, it's going up $200 per year. The average rate of change in this account tells us that from year 2 to year 4, the account went up on average $200 per year. From year 2 to year 4, the account increased $200 per year. If an average rate of change is positive, that means the function is increasing. If an average rate of change is negative, the function is decreasing. Let's look at a real-world example from an actual function itself. The height in meters of a printed version of a Math 110 book thrown up into the air for t seconds can be given by this function below. H of t equals 16t minus t squared. Find and interpret the average rate of change from t equals 1 to t equals 3. So we need the corresponding outputs. Let's find h of 1 and h of 3. If I plug in 1, 16 times 1 minus 1 squared will give me 15. H of 1 equals 15 tells me that after 1 second, the book is 15 meters in the air. If I plug in 3, 16 times 3 minus 3 squared will be 39. That tells me after 3 seconds, the book is 39 meters in the air. So the average rate of change is the change in outputs, 39 minus 15 over the change in inputs, 3 minus 1. That is 24 meters in 2 seconds. So in 2 seconds, the height of the book increased 24 meters, or in other words, 12 meters. per second. This tells me from 1 to 3 seconds, the height of the book increased 12 meters per second. In part B, find and interpret the average rate of change on the interval 8 to 11. That is interval notation. Those represent inputs. That is the same thing as saying from t equals 8 to t equals 11. That's how we're to read that interval notation, since it's brackets and not parentheses. That is not the same thing as a point. That is the same thing as saying input values. So we need to find h of 8 and h of 11. If I plug in 8, 16 times 8 minus 8 squared will give me 64. And if I plug in 11, 16 times 11 minus 11 squared is 55. What those mean is that after 8 seconds, the book is 64 meters in the air. And after 11 seconds, the book is 55 meters in the air. In other words, if you think about that, from 8 to 11 seconds, the height of the book actually decreased. The book is coming back down. So if I compute the average rate of change here, the change in outputs, 55 minus 64, over the change in inputs, 11 minus 8. I will get negative 9 over 3. That's negative 9 meters in 3 seconds. In other words, the book came back down. It's falling 9 meters during that 3-second period, or negative 3 meters per second. This tells me from 8 to 11 seconds, the height of the book decreased 3 meters per second. If we have a positive average rate of change, the function is increasing. If we have a negative average rate of change, the function is decreasing.